Hello and welcome to another video. In this one, we're going to be talking about coverage, what that means, and I'll also introduce you to how it works, or how CoveragePy, one such coverage tool in Python, works, and kind of the basics there. But anyway, let's jump into it. Okay, so coverage is a way to measure what code gets run and what branches get run. Usually it's very useful to know whether your tests are actually validating the code. There's the term 100% coverage, saying that your tests cover every single line of code in your project. Now that doesn't mean that there aren't bugs, but it does give you some amount of confidence that your code is actually testing things. And there's kind of two approaches to coverage. First is what's very popular in compiled languages, mostly because there isn't a way to do the second one, which is they will compile code and they will insert particular measurement calls in between each executable line of code or executable branch or things like that. They'll basically have a special compile option that allows you to instrument the code that's running. This is how, for instance, gcov works, which is a coverage utility for C and C++. The other option is really only available to interpreted languages, which is the coverage utility instruments the runtime of the language such that it works differently. This is how CoveragePy works. For instance, if we look at Python, there is this sys.setTrace function, which allows you to put a tracing function here, and it's really noisy. But here, I'll show you just how noisy, just how often this function gets called. You'll see here that anytime a line is called, it's going to tell you the frame that's being executed, what's happening, and some other information that I don't know too much about. I think this is the return value or something, but it gets called a whole lot. And so you can imagine tracing a program via sys.setTrace can be pretty slow. And so coverage has to do a bunch of things to make it not slow. Most of that is around compiling to a C extension and doing some other stuff that makes setTrace less overhead than. And actually, this is the same functionality that debuggers in Python use. So if you do breakpoint here, it's going to drop us into a breakpoint. You'll see just how much code had to run to even trigger the breakpoint. But now that we're in this breakpoint, you'll see that our original set trace from before, which was printing everything, is now gone. And that's because the breakpoint system also uses that. But anyway, we're super off topic. We're talking about coverage today. Okay, so that's kind of the two basic forms of coverage, which is, inject code into a compiled output. I know there's a JavaScript library that does it this way too. And then there's instrument the runtime, which is how CPython, or how CoveragePy does this in CPython. But now I wanted to show you quickly what CoveragePy is, some quick demos of how to get started with running it, and how to ignore coverage and some other stuff there. So let's set up a virtual environment and activate it and pip install coverage. We'll install CoveragePy, which gives you this coverage binary. Coverage has a whole bunch of different commands that you can, subcommands of it that you can run. We're mostly going to be interested in the run and the report. These other ones are kind of useful, and I guess we'll also maybe use erase as well. But we're mostly going to be looking at run and report. Run is kind of the entry point to coverage. Normally, there are other ways to run coverage via the Python API, but for the most part, I use coverage run. And let's actually install PyTest, and that way we can actually show test coverage here rather than just Python coverage. And I'm going to make a function here. I don't know. Print age, sure. Not a very good function, but a function nonetheless. And let's say if I is less than 0, we are going to print you are not of age yet. I don't know. And otherwise we're going to print hello, your age is I. Extremely silly example. We're going to write some tests for this. Test negative age. And we're going to test the output of this. I did a video on testing the output. I'm never going to remember to link that in the description, but maybe it'll be there. Where we're going to call print age with -1. Actually, let's not call this first. Let's just do test print age. And we'll just call it with a positive number so we can show what it looks like when we don't cover code. Out air equals capsys.read out air. Insert out equals hello, your age is 2 with a new line. And here is the empty string. Okay, cool. So now if we do coverage run -m pytest, this is run coverage, used pytest as our module that we are running, and we're going to pass t.py as the input to pytest. And you'll see pytest runs here. There's no other special output, and that's because coverage has written out this little .coverage file. This is a database that includes all the coverage information. Interestingly, it has recently changed to be a SQLite database, so you can inspect the schema and look at the tables and stuff directly. I don't know whether this is a documented interface or not. I know it was a big deal when it switched over, but I occasionally find this database useful to see the exact data that it shows. But we're not going to poke around in there today. But anyway, it will create this coverage file, and this includes all the information about which lines were run and some other bookkeeping and stuff as well. And we can display that in a human readable format by doing coverage report, which will show us the files that we ran, how many statements are in there, whether we missed any of them, and the percentage. Now I find this default output not super useful, so I usually like to do show missing, which will show you the line that's missed. If we go to line 6 in this file, you see this doesn't get covered at all. I also like to enable what's called branch coverage. Is that done here? I don't remember the option because I set up a plugin that sets all of the defaults that I always use. And this plugin is called covdefault. But since we're actually doing a video on this, I feel like I should. Oh, it's in run. Okay. So we need to actually rerun our tests with branch coverage enabled. I believe that's done by doing -- branch here. And now if we do coverage report, it's without the branch option. You'll see that we now have these branch columns here. So you'll see that there are 2 branches, and one of them was missed, and that is the branch that goes, well, why didn't it show us the actual branch? Oh, because there's a line missing here. Yeah, if we had somehow covered this line or like only tested when this was true, I guess we could do that by doing this. Let's just comment this out so we get just a branch failure. Branch report. Yeah, okay, so you can see here, this is what it'll look like if there's a branch missing. So this is telling us that there is never a branch from line 5, which is this line right here, to exit. Exit is usually returning the function or returning from the module or returning from that scope. So what it's saying here is that this is always true. There's never a case where this branches to the imaginary else here. So that's kind of the basics of run and report. Now, sometimes you might want to tell it, okay, I know this never branches, but it's still important for the code to be here. So you can use what are called pragma comments. These are built into coverage. You can customize them, but these are the default ones. You can do pragma : no branch. This will tell the coverage reporting mechanism that yeah, we know that this line doesn't branch to, we don't test that this line branches in the negative case, but it basically allows you to ignore parts of coverage. There's also ignoring line coverage. So if we go back to the original version, and we know that this is not tested, and we intentionally don't want to test it. Now we are actually going to go and test this in a second. You can do pragma no cover. Oops, that's off screen. This is the comment. And actually, you can put this on the if statement itself. That way, it's basically saying that this whole branch or this whole chunk of code is not covered. And if we rerun this and then report again, you'll see that it has marked this as covered. This is a lot more apparent inside the HTML report. Do coverage HTML. This will generate a little HTML app, which we can open in a browser. And it will color the lines based on whether they're covered, ignored, or otherwise. And so, well, I can actually click through to the file here. So you can see how they're colored gray here, and that's because they are in this excluded category. Whereas if we had not ignored them, this, and run and HTML, and refresh this, you'll see that we get partial. This is a branch miss here, and we get one missing, which is this this line is never covered here. Now the other option that I like in report is to make not make it an error when there are not enough things being covered. And you can do that by doing fail under and then give it a percentage. So this is what I usually do, which is to require 100% coverage. And now this command will exit non-zero if that coverage is not hit. Then if we went in and test print age negative age, and we wanted to actually test that other case, age -1, copy our assertions here, but adjust them to say, you are not of age yet. Now if we run again, and oops, we are missing a new line there. Okay, we run that again and report again. You'll see that this now has 100% coverage and it exits 0, meaning it's successful. But anyway, that's kind of the basics of code coverage. It's a useful tool to figure out whether tests are actually testing code. I also introduced the concept of branch coverage, showed you how to ignore coverage, and also showed you the nice little HTML report. Oh, I want to talk about one other kind of cool use case that I've used for coverage before. And this is like not the intended use, but at the same time, kind of a neat one. I've used coverage in production at a small sample rate to figure out which code actually is being run. When code bases get to a certain significant size, it's hard to keep the entire code base in your head and know whether your functions are actually being used or not. So I basically set up a sampler, which made some of the requests slower, since instrumenting the code as it's running takes some amount of computation. But it gave me a better confidence about whether a piece of code was being run or not. But anyway, kind of a fun little usage of coverage. And anyway, if there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.